Naming hydrocarbons with side chains or alkyl groups is very similar to naming with an unsaturated bond in that you need to identify the location of those side groups. So let's take a look at this first example. Here I have a hydrocarbon. I know it's a hydrocarbon because the only elements in this particular molecule are hydrogen and carbon. The next thing I did for step 2 was to circle the longest carbon chain. This one is a little bit tricky. You do have to count at every location. If I look, this long chain clearly looks like the longest chain, but you should also count to make sure. For example, I should count to make sure that 1, 2, 3, 4, 5, 6, 7, that's only 7, that wasn't the longest chain. Or 1, 2, 3, 4, 5, 6, 7, 8, 9. That's also 9, similar to the one I've circled. So I just have to pick which one of those 9 I'm going to count as my longest carbon chain. Since I like to use the center one if possible, I circled the longest carbon chain as this center one right here. Knowing that I have 9 carbons, I take a look at table P. On table P, you'll see that 9 is non, that's my prefix. Since all those carbons are single bonded together, I go to table Q and I look and see the picture here in the structural formula shows me that the carbon-carbon bonds being single makes it an alkane. So I know that I have 9 non, alkane, end with ane. So what I've circled is nonane, but that's not the entire molecule because there's clearly things that I have not adjusted yet. Okay, so let's address those other side groups. I have my nonane right here, but off the top here, I have a 3-carbon group. Again, go back to table P. 3 carbons is prop. So I know that it's a prop group, but anytime I have a side chain off the main chain, I end it with YL. So I'm going to call that group propyl. Likewise, on the bottom, here's another group. In this case, there's only 1 carbon off the main chain. So I come back to table P. 1 carbon means meth. So the prefix for this group is meth. But again, side chain ends with YL, so this group here is called methyl. So I have a propyl up here, and I have a methyl down here. The next step, this is where it becomes very similar to the double or triple bonds. You need to identify the location of where those groups are. So if you take a look, I numbered my carbons from left to right. Again, can't always tell you to number it from left to right. You have to try it from right to left also. But when you try it from left to right, you do end up with these side chains on carbons 3 and 4. If I numbered it from the other direction, those side chains would have been on carbon 1, 2, 3, 4, 5, 6, and 7. 3 and 4 is smaller than 6 and 7. That's why I have to count from the left side in this case. So if you look, the methyl group is off of carbon 3. The propyl group is off of carbon 4. So that's my next step. Now let's put it together. I have methyl, 3-methyl, and 4-propyl. And remember, the original substance was called nonene. The last thing I just want to mention is that they should be in alphabetical order, your side groups. So methyl, being that it comes first in the alphabet with the M, should come first. 3-methyl, 4-propyl, nonene.